All right, piling it on. 7-3, day 2 pre-lesson. Now, this is strange math. Hang tough. First of all, let's talk about some basic things you've been taught since you were a wee child. A triangle always has three sides. So we're using trigonometry. We've got this little drawing here. That's got to be my reference angle. So that's my opposite. My spinner's my hypotenuse, and here's my adjacent side. Basic. Got to have three sides. Or do you? See, that's the question. Trigonometry trumps geometry and says, no, you got to use your imagination. The triangle's not there, but it is there. I know it's confusing, so let's talk about it. So we're going to enter into these weird things called quadrantals. Quadrantals are spins that land right on the x or the y-axis. For example, let's take 180 degrees. 0 plus or minus 90, plus or minus 180, 270, 360. All of these are quadrantals. Now, 360 could be 720 because all that is going on twice. And you end up in the same place as 360, which is the same place as 0. Now, let's talk about this 180 thing. If I said, okay, where does my spinner stop? Well, it goes up here, and it lands right smack dab on the x-axis. So where are their triangles? Remember, if I said 145, you'd go, aha. I'm going to go like this, 90 plus, whatever, 55, and I can stop right there, and I go, hey, come back to the x-axis. Build your right triangle. There's your reference angle. If I say 180, it's like, wait a minute, I don't even have a triangle. But Trig says you do. Now, with that in mind, let's get started. What about a 0-degree spin or a 360? So it's like, okay, 0 degrees is like, okay, I'm done. 360, same spot. Negative 360, same spot. So how do we calculate these things without a calculator? See, if you take your calculator right now and you figure stuff out, like sine of 360, tangent of 360, it's going to give you an answer, which is really bizarre, because technically there's not a triangle. But you need to think this. So 0 degrees, 360, you got to go just a little above the x-axis, let your brain process. So remember, the spinner is my hypotenuse. I always create my triangle by going back to the x-axis. Now, technically, there is no triangle, but we need to build one close to 0 degrees just so we can process what trig says. Now, with that being said, this guy right here, my opposite side, remember this little sliver, which is 0 degrees, but that's my reference angle, has an opposite side. But that opposite side is non-existent. It's 0. Now look at this side. This is my adjacent side. Now if I literally had that thing come down and laid back down here, then I would say my hypotenuse and my adjacent side are the same. I'm going to get my drawing back there. You see, drawn like this, I can look at this and go, aha, my hypotenuse equals my adjacent, but my opposite side is 0. It disappears. So what if I said find sine of 360? Well, remember, that's opposite over hypotenuse. Now we need to stop and think for a second. Here's a quick something. 0 over some number, remember mathematically, is 0, like 0 divided by 10, 0 divided by 20. But what if I flip those and I go some number divided by 0? Mathematically, that's undefined. You can't divide any number by 0. It's impossible. Keep that in mind as we keep going. So if I said, hey, find sine of 360. Well, here's my drawing. What do we say happens to my opposite side? Technically, it's 0. What's my hypotenuse? Doesn't matter. It could be 20, it could be 12, it could be anything. So I'm just going to put a random symbol for a number. And what's 0 divided by anything? That's 0. Now take your calculator and just type in sine of 360. Make sure you're in degree mode. And then your calculator should go, 0. That's y. Okay, so you're gonna have to do these things without a calculator. This is just the beginning. Let's talk about 90. We're all a little different. So, first of all, I gotta spin my spinner 90. Here it is. A true 90-degree spin would take me right here, right on the y-axis. I'm like, there's no triangle. You're right. And you're kind of wrong, because you need to think, here's my spinner. If I go 90, it's going to hide the triangle. So I'm going to stop just shy of 90. Do your best drawing it. Now remember the golden rules. To create your triangle, you always come back to where? To where? The X. So don't make this little mistake coming back here. You got to come back down here. Now let's look. If this is my reference angle, which it is, this is my opposite side. This is my spinner, so it's my hypotenuse. And you see that little small guy? That's my adjacent side. The small guy in your imaginary picture always disappears. That's your zero. And also, my opposite side equals my hypotenuse. I know this is a strange concept. So let's say I'm trying to find sine of 90 degrees. But remember, they can give it to you in a fancy way. They can say find sine of pi over 2. Same problem. Like, okay, spin your spinner up here. Uh-oh, I can't see anything. Right, that's why you got to stop here. Let your mind process things. Sine is opposite over hypotenuse. Now, I know that they're equal. So it might be 10 and 10, 3 and 3, whatever. It's some number divided by itself, and that's going to equal 1. Test it out with your calculator. Sine of 90. Enter. Ding, 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 ding. 1. Let's talk about 180. If I literally spun at 180, it would land right here and stop. Like, I can't see it. I don't see a triangle. That's why you want to stop just shy of 180. Let your mind process. Come back to the X and think for a second. This is your hypotenuse. This is my adjacent. This is my opposite. Now there's a twist here. My opposite is my shorty, so that's what disappears at 180. But remember, this is my left direction, so now my adjacent side is to be considered a negative distance. Left. You've been doing that a long time. So what does this mean? It means my hypotenuse equals my adjacent side. So if this is 10, that's 10. If that's 6, that's 6. Hypotenuse is always positive. Well, my adjacent side is negative, but they're equal. And then my opposite side is the guy who disappears. So let's try to find, I'll just say tangent of 180 degrees. I can say it the same way by saying tangent of pi. But we know it's TOA, opposite. I'll put the T so there, so you know it's opposite, not a 0. All right, what is the opposite side? Well, it disappears. What's my adjacent side? Well, it's got a length, and it's negative, but you know what? 0 divided by anything is 0. Now, what if I said cotangent of 180? Well, it would just be this thing flipped, so it would be a negative number over 0, and go, whoa, can't have that, undefined. Let's go 270. If I literally did it, it would go here, and my spinner would end up right about there, right on the y-axis. Can't see it. So what have I been telling you? If that happens, if it's a quadrantal, take your spinner, spin it all the way around, but then stop just shy of where you're supposed to go. Always go back to the X. I hope you're picking up on this, and let's analyze this information. If that's my reference angle, that makes this the opposite. That makes this the hypotenuse, because that's my spinner. And that little shorty has to be my adjacent side. So my adjacent side disappears. My opposite side equals my hypotenuse, but wait a minute, this is down. So that has to be negative, a negative version. So if I said, okay, I'm just randomly picking this out. What if I said sine of 270? Well, that's opposite over hypotenuse. And I'd say, okay, well, what's my opposite side? I don't know what it is exactly, but I do know that these two things are equal. So it's a negative number. These two things are equal, remember? See this? Over itself. So that's like negative 10 over 10, or negative 6 over 6. We don't even have any dimensions. We don't need any dimensions because we know that it doesn't matter. It's not based on the size. So we would get negative 1. Type it in your calculator, sine of 270, see if it's true. Now what if they start throwing negatives at you? Well, all that means is you start here, negative 270 would mean go this way, and stop here. Well, that's the same thing as if you were to spin your spinner up 90. So if you're going to stick with the 270, you could stop right here and draw this down. Here's my adjacent side, that's the shorty, so that's the 0. Here's my opposite side, which is positive because it's up. And here's my hypotenuse, which is always positive. Now, what if a student decided to go with the 90? Well, they would flip it up here. They'd stop just short, come back to the x. Here's my opposite. My hypotenuse is here. Just leave that HYP there. And here's my adjacent side. So the rules would be the same, so the trig would be the same. Just wanted to show you that. So let's try a few. Tangent of pi over 2. Well, 180 over 2 is 90. So I take my spinner, spin it up, stop just shy, come back to the x. Here's my reference angle. Opposite is the same as hypotenuse, and my adjacent is 0. Tangent is coa, opposite over hypotenuse. Whoops, wrong. Adjacent. Well, my opposite side is some number. It could be a 10, 12, 20. The adjacent side, 0, undefined. Check it with your calculator. What about pi? Well, that means take your spinner, go 180, stop just shy, create your triangle. There's my adjacent side, gotta be negative. Here's my hypotenuse, and it's my opposite side that disappears this time. So tangent, again, is opposite over adjacent, so it's 0 over some negative number. So it's 0 over some negative number, and that is 0. Now let's go to 3 pi over 2. Well, that's the same thing as 270, so stop just shy, create your triangle. There's my opposite, gotta be negative. My adjacent side is the one that disappears, and there's my positive hypotenuse. Following opposite over adjacent, I got a negative number for my opposite. My adjacent is 0, undefined. 2 pi is just 360, which is the same drawing as 0. Well, I haven't done that one yet. Am I still on the board? Sorry, I'm going to squeeze this in. So that would be there. There's my opposite side. That's what equals 0. Hypotenuse adjacent. So tangent is opposite, 0 over adjacent, some number, and that's 0. Again, play with your calculator to confirm these things. Last problem of the pre-lesson. Secant, cosecant, cotangent. Remember, that's the reciprocal of tangent, reciprocal of sine, reciprocal of cosine. So let's say I'm just grabbing one randomly. They want us to find cosecant of 2/10. We draw, there's 180 plus 30, stop. So I know this is 30, create your triangle. I have my 30, 60, 90. So this is my 1, this is my 2, this is my square root of 3. But because I'm over here, that's a negative negative. Now what is cosecant the reciprocal of? Sine. So I'm going to find sine of 2/10, watch this. Opposite over hypotenuse. But then if I remember cosecant is just the reciprocal of sine, I can flip it and be done. So that's what you're going to do. When you get presented with these, find its reciprocal function, then flip it.